Welcome to the first class I'm going to set up about welding. This is kind of just an introduction to it. We're going to talk about some basic principles dealing with what to look for or what actually has to happen when we're welding. And this is going to be for SMAW, or shielded metal arc welding. And I'd like to kind of talk about some of the things that have to happen in order for that process to work. So the first thing is we always kind of cover an acronym. We call it C.L.A.M.S. So C.L.A.M.S. And what that is, just a way to remember the things that you have to keep in mind while you're welding to make sure that everything's going properly, right? So when we first start welding, you're going to have problems. You're going to be sticking, or there's not going to be a nice bead that you've run. It's going to be all scattered and splatter and all kinds of different things. And we'll talk about kind of what each one of these do. But if you're having problems welding and it doesn't look like you think it should look, right? You've watched all the videos and things, and the bead you've come up with doesn't look all that neat and doesn't look all that professional. Here's some of the things you can kind of look at to adjust what you're working with and how you're doing. So the first one is C, and that's going to stand for current. The current is how much electricity is flowing through the electrode you're using. And the electrode is of course the rod that we've got. So whether it's a 60-10, 60-11, 70-18, anything like that, those are the type of rods you're going to put in your electrode holder. And as you're taking that rod down the plate, you have to have it be at a certain temperature or electrical current level. And what it is the thicker the metal, the thicker the rod, the higher the current you want, right? So that way, when you're melting the plate at the same time as you're melting your rod or your filler metal, and so it's making a puddle of the plate or the base metal, and then you're mixing in that filler as it melts into that puddle, and you're creating an alloy. And the alloy is the mixture of the base metal plus the filler metal that you're adding into it. So you want to make sure they're all melting at kind of the same rate so that you can take and have a really nice smooth weld. And so that's really how you get the best penetration and the best fill in. The next one we'll talk about is length of arc. Length of your arc is the distance from the end of your electrode to the base metal. So the gap in between the rod and the base metal. Good rule of thumb to go by is the gap or the length of your arc should be the same or close to the diameter of your rod. So if you're using an 1/8 inch rod, you want roughly an 1/8 of an inch between the end of your electrode and the base metal. So that's going to be length of arc. If you're too far away, it'll melt and it'll hit the plate and it'll splatter, or the base metal, and it'll splatter and create all kinds of little ghibli bits all over your plate. So you've got, splatter they call it, or spatter. And so you've got a whole bunch of little BBs all over your plate. Well, and you're not necessarily you're melting the base metal and you're melting the rod, but when they hit, they've already kind of cooled off and they kind of just make a glob right there on the plate. And that's so if you're too far away. If you're too close, you can burn through the plate. You're creating all of your heat into that plate, and you're basically burning very deeply into that base metal. And what it'll end up doing is you're going to have a big hole, or you can burn through your plate. Or if your amperage isn't up high enough on your current, you can stick to your plate very badly because you're too close. And really that's more of a current problem than a arc distance problem. So we're going to try to stay roughly the diameter of the rod itself away from the plate. And you'll see a little bright, shiny light there when you start to strike your arc. Our next one is going to be angle of our electrode. On a flat piece of metal, as you're running your electrode down your flat piece of metal, angle matters a little bit, but it's not serious. So when you first start, we'll have you putting welds and putting beads onto a piece of metal that's laying flat. Where this really comes into play is if you're going to be welding something on its side. So instead of taking your rod and hitting the side, your base metal on the side straight in, well, what happens when you have water and you try to spray water on the side? Well, it would run down, right? Well, you've basically liquefied the metal. So when you go to melt the metal melt the base metal, it'll start to run out. And when you melt the filler metal into it, it'll also add to that, make it run out. So you'll have a big etch in the side of your plate, and you'll have notches cut in it where you've melted it, but all the weld is going on the bottom side. So what you'll end up have to do is going at an angle. So your angle of electrode matters. You're going to heat it, you're going to add to your pool, and then you're going to push it back up. You're going to melt it, add to your filler to it. It's going to kind of drip down. You're going to push it back up. So you're going to keep walking that weld and that bead back up into the etching that you've made on the side of the base metal. So that's going to be our angle of electrode. The next one is going to be manipulation of puddle. That's going to come into play too. And I always kind of talk to people about manipulation of puddle as if you have a piece of cardboard and you take a crayon and you put a lighter on it and you melt that crayon, you can melt that crayon, keep it burning, and as it melts, it puts a little puddle on top of that piece of cardboard. And if it keeps melting, you can just kind of walk that puddle around and you can keep melting it. You can kind of mush it one way or the other and put that wax where you want to do it. Same thing works with welding. As you melt the base metal and you melt your filler rod into it, you can kind of walk that metal back and forth, and you can mush it one side or the other, uphill, pull it downhill if you need to. You can walk it into a crease if you've got a T-joint or any kind of a joint. You can walk it into that crease or walk it up the crease. If you're welding vertical, you're going to start pushing it up, right? You're going to make it go up the metal that you're melting. Okay, so manipulation of puddle is crucial to being able to put the weld where you want it. And the last one is speed. So there's two types of speed. There is the speed at which you are walking forward, and then there's the speed at which you're going side to side if you're doing like an oscillation in the bead you're laying, right? You can go a straight bead where it melts in a straight line, or you can manipulate your puddle, go back and forth just a little bit. And if you go back and forth just a little bit, if you go too fast, it'll look like a spring or a zipper, a Z that's been sprung, right? You've got a line here, line here, line here, all the way down, where, so I can draw it on here maybe a little bit. If you go too fast, you'll have a weld here, and you'll go up at a line here, go up at a line here, go up at a line here. You're not really attaching those two plates together because you're not creating a consistent bead. Whereas your speed, if it was just here, going to this side, and then walking back to this side, over this side, back to this side, back to this side, now you've got a complete bead and you filled in what you've etched away. So it's not necessarily how fast you go down the line, it's how you're making sure you don't leave your puddle behind. So as you're melting your filler rod into the base metal that you've melted there too, you want to make sure you're going slow enough that you never leave that puddle behind. Because like with the wax crayon, if you melt it and you go too fast, it'll create a blob, and then another blob, and then another blob. If you stay in the puddle and you keep melting it to that wad there, it'll make a really nice bead all the way down. So that's pretty much all I wanted to cover today. I hope this makes sense. This is kind of just one of an introduction class. So we're going to talk a little bit more about the actual process a little later.